Okay, so this graph is it's a little bit tough because we have that absolute value in the denominator, and the absolute value is actually going to do something to this graph. Okay, so let's start off with just our zeros here. Okay, so let's go for our zeros. The zeros are going to be at x equals 0 and x equals -1. So let's put those in. Okay, so at x equals 0 and x equals -1, I have zeros there and there. Okay. Now there are some restrictions here because if we take a look at this function, this at -1 is going to be a restriction. Okay, so we know that this is going to be maybe just a restricted point. So we got to be careful of that. So it looks like it's going to be equal to 0, but I'm going to put it as a whole. Okay, because we know that's a non-permissible value. Okay, so we have, looks like we have potential, it's a non-permissible value. That's the only actually place where it equals 0, and in fact it looks like it's going to cancel out, so it doesn't look like it's going to be vertical asymptote, it looks like it's going to be a hole there. Okay, so let's work out this positive and negative domain here. The positive domain is going to be when the boundary is going to be -1, and if I go to the left of -1, so the more negative numbers, that's going to be negative, and I'm going to have to apply the absolute value. So the negative domain is going to be when x is less than -1. So then the positive domain will be when x is greater than -1. Okay, so if x is greater than -1, okay, we have positive domain. All right, so we should really then work out the piecewise function for this. Okay, so here's my f of x, and I'm going to have negative and positive parts of this function. So I'm going to start off with the negative domain. When this is negative, I'm going to end up with x plus 1 divided by, that's going to flip to negative x cubed plus 1. Okay, so that's my negative. My positive is going to look like this. The positive domain, it doesn't change, so it's just going to be x plus 1 over x cubed plus 1. All right, so, and this is, I better write my domain in here. So this is when x is less than -1. This is going to happen when x is greater than -1. Now, x cubed plus 1 and x plus 1 share a common factor because when you factor x cubed plus 1, x cubed plus 1, if you notice, this is really handy, but it's going to look like this. This is a cube. There's actually a formula for this. So it's going to be minus x plus 1. Okay. Now, if you don't know this formula, that's fine. You could always work this out. But it is this is the sum and difference of cubes formula. There is a sum formula here, and there's also a difference formula. Okay, so there it is. So I'm going to simplify these expressions. Okay, so f of x then is going to equal, based on my negatives and positives. So I'm going to do my negative first. These terms are going to cancel out, so I'm going to end up with negative x. I'm going to put the negative on top, and that's all over x squared minus x plus 1. Okay, so that's the negative version of that. The positive version of this, again, is going to share the common factor. So the positive version is going to cancel out with x plus 1s, but it's going to be x over x squared minus x plus 1. Okay, so these have no zeros, so there's no vertical asymptotes. So the only restricted value that we have was -1, and we kind of dealt with that already. It's going to be a hole there. So what is this graph going to look like? Okay, so there's no vertical asymptotes. What about horizontal asymptotes? What's going to happen to this graph? maybe I should make sure I put the domain in here. What's going to happen to this graph as x goes to positive or negative infinity? So let's do the limit as x goes to negative infinity. We have weak over strong. Okay, so that's going to be 0. And for the other part here, we're going to have the same issue. As x goes to positive infinity, we're going to have weak over strong, so we're going to have 0. So it's going to go, we're going to have horizontal asymptote here, and we're going to have a horizontal asymptote here. Okay, so as it goes out to infinity, it's going to go to those horizontal asymptotes. Okay, so it looks like we're probably, let's just check our continuity now. We have to check our continuity at x equals -1. So I'm going to do that with a limit, but we can just plug in. Basically, we're just seeing at x equals -1, we're going to get, what's that, 1 divided by 1 minus 1 plus 1, 1 over, we're going to get 1/3. Okay, so I'm going to write it formally like this. The limit as x approaches -1 from the negative side, we're going to end up with positive 1/3. Just double check that, positive 1, positive, positive, positive. Okay, so that's going to be positive 1/3. And the limit as x approaches -1 from the positive side, we're going to use the bottom function. So we're going to end up with negative, positive, positive, positive. So it's going to be -1/3. Okay, so it looks like there's not a hole there. It looks like as we approach 1 from the negative side, it's going to equal to positive 1/3. So I'm going to scale my axes here. So I'm going to make that equal to -1. Make that into positive 1. So from the positive side, it looks like it's going to approach -1/3. So right about there. And from the negative side, it's going to approach, it's going to be like that. And from the negative side, it's going to approach positive 1/3. So it's going to be like that. Okay, so these are some pretty, there's lots of things that we have to consider here when we're drawing this function to keep track of. So we need to be very organized with this. So I've got my asymptotes figured out. I have my 0 figured out. Okay, I have this point of discontinuity, and I know exactly what's happening here. It's a hole there, but it's a hole going to this point from the right side, and a hole going to here from the left side. Okay, so it's different. The last thing I want to do is I do want to find min-maxes. Okay, so I'm going to have to differentiate this function. Okay, so the derivative of this function, we're going to do a slope chart here. Okay, so let's differentiate the simplified versions of this function. So I'm going to write my f prime over here. So f prime of x. Okay, so it's going to be equal to, so my negative version is going to be -1 times x squared minus x plus 1 minus -x times 2x minus 1. Okay, and that's all over x squared minus x plus 1 squared. Okay, which I'm going to simplify to, this is going to be positive 2x squared, negative x squared there. Okay, so I really should maybe factor out that negative, but that's okay. So really the only difference between these two functions is a negative. So I'm going to just work this out, and my green function is just going to be the opposite version of the red function. So I'm going to simplify, so negative x squared plus 2x squared. So that's going to give me positive x squared. I'm going to get positive x, negative x. So those x's cancel. So I'm going to end up with minus 1. Okay, and that's going to be all over my denominator, x squared minus x plus 1, all squared, and that's for x less than 1. less than negative 1. Okay, so I can then see that when x is less than 1, I have a critical point at negative 1, positive 1. So but at negative 1, it's undefined. So it looks like it's just going to go up and go up to that like a maximum point. Okay, so at negative 1, it's kind of undefined, but it looks like it's going up to that point. Now my negative, the other derivative is going to be the exact same thing, but negative. So it's going to be negative x squared minus 1 over x squared minus x plus 1 all squared. And this is for x greater than negative 1. So the 0 here at positive 1, okay, that is in fact a min or max point. So I'm going to test my derivative. At 0, I'm going to end up with a positive slope. Okay, so at 0, it's got positive slope. So it's going up. It's going to go across like this at 1, at x equals 1. And we should find out the y-coordinate of that. And when x is bigger than 1, when I plug in x is bigger than 1, I'm going to end up with positive. And then that negative on the outside makes it negative. So it's going to look like that. Okay, so I think I had a chart here. No, I didn't make a list, a table of values, but I do need a table of values for, I do need to know the x coordinate, sorry, the y coordinate when x is 1. So I'm going to plug that back into my original function. When x is 1, I'm going to get 2 over 2, and that's going to be y equals 1. X is 1, yeah, that looks like y equals 1. So x is 1, y is 1. So I'm going to have that point there. Okay, so my graph is going to look like this. It's going to have a horizontal asymptote at 0. It's going to come up to that point. Okay, I don't know if I tested the slope, but I should test the slope on that side. Okay, a slope, if I plug in negative 2 into here, I'm going to get a positive slope going into here. Okay, so there's my positive slope. That goes to this coordinate right there at negative 1 and 1/3. I better put those into my table here. Negative 1, positive 1/3. Okay, I have at negative 1, negative 1/3 is the other coordinate. Okay, at 0, I have a 0. At 1, I have coordinate 1. So it's going to go up through there, touch that point. Okay, at positive 1, and then it's going to come back down. It's going to go along the asymptote like that. Okay, so there's my graph. I think I've got all the parts here. Yeah, I've got my positive slope through there. Everything seems to coincide. I've got my piecewise function here. I've simplified that piecewise function. I've established my what's happening at the hole using my limits. Okay, I have my horizontal asymptotes here. I've worked out my derivatives, and again, I've evaluated my derivatives on either side, depending on which function I'm going to use, depending on which side of negative 1 I'm at. Okay, so there we go. There is the whole graph. There's a lot involved in there, but there it is.